Lesson: Adaptive Access Controls Powered by Machine Learning. Adaptive access controls powered by machine learning represent a significant advancement in identity and access management, offering a dynamic approach to safeguarding digital assets. In traditional IAM systems, access controls are often static, relying on predefined rules that may not account for the dynamic nature of user behavior or emerging threats. Adaptive access controls, on the other hand, utilize ML algorithms to continuously assess and adapt to contextual information, providing a more nuanced and responsive security posture. At the core of adaptive access controls is the ability to analyze vast amounts of data to identify patterns indicative of legitimate or malicious behavior. This analysis is achieved through various ML techniques, such as supervised and unsupervised learning. Supervised learning involves training models on labeled datasets, enabling the system to predict outcomes based on learned patterns. For example, a supervised learning model can be trained to recognize the typical login patterns of users, allowing it to flag deviations that may indicate a security threat. Conversely, unsupervised learning deals with unlabeled data, employing clustering or anomaly detection techniques to discover hidden patterns without prior knowledge. This method is particularly useful in identifying zero-day threats, where the system learns to recognize anomalies in access patterns that deviate from the norm. Practical tools like Apache Kafka and TensorFlow facilitate the implementation of adaptive access controls. Apache Kafka, a distributed event streaming platform, can be used to capture and process real-time access events. By integrating Kafka with ML models, organizations can monitor user activities continuously and make instantaneous decisions. TensorFlow, an open-source ML framework, provides the necessary libraries and tools to build and train complex models that can classify, predict, and adapt access controls based on real-time data inputs. For instance, TensorFlow can be employed to develop models that assess risk scores in real time, dynamically adjusting access privileges based on contextual factors such as location, device, and time of access. A practical application of adaptive access controls can be seen in the banking sector, where the need for robust security measures is paramount. A case study involving a leading bank demonstrates the efficacy of this approach. The bank implemented an adaptive access control system powered by ML to monitor and evaluate login attempts. By analyzing historical login data, the system established baseline patterns for each user. When a login attempt deviated significantly from the established pattern, such as an unusual geographic location or an atypical time, the system triggered additional authentication measures. This proactive approach not only enhanced security, but also improved the user experience by reducing unnecessary friction for legitimate users. One of the primary challenges in deploying adaptive access controls is the potential for false positives, where legitimate user actions are incorrectly flagged as suspicious. This can lead to user frustration and potential loss of business. However, by employing advanced ML techniques such as ensemble learning, organizations can mitigate this issue. Ensemble learning involves combining multiple ML models to improve prediction accuracy. For example, by integrating decision trees, random forests, and neural networks, an organization can leverage the strengths of each model to reduce the likelihood of false positives while maintaining robust security measures. Moreover, the implementation of adaptive access controls must be complemented by a strong ethical framework. As these systems rely heavily on data, ensuring user privacy and compliance with regulations, such as the General Data Protection Regulation, is critical. Organizations must establish clear data governance policies, ensuring that data collection, processing, and storage practices adhere to legal and ethical standards. Transparency in how data is used and the ability for users to opt out of data collection are essential components of a responsible adaptive access control strategy. The effectiveness of adaptive access controls powered by ML is further validated by statistical evidence. According to a study by Gartner, organizations that deployed adaptive security measures reported a 60% reduction in security incidents compared to those using traditional IAM systems. This significant reduction underscores the potential of ML-driven adaptive systems to enhance security while providing a seamless user experience. In conclusion, adaptive access controls powered by machine learning represent a transformative approach to identity and access management. By leveraging advanced ML techniques and practical tools, organizations can create dynamic, context-aware security measures that adapt to evolving threats. Through real-world applications and case studies, the benefits of this approach are clear enhanced security, reduced false positives, and improved user experience. However, successful implementation requires careful consideration of ethical and privacy concerns, ensuring that data-driven security measures align with regulatory standards and user expectations. As the digital landscape continues to evolve, adaptive access controls will play a crucial role in safeguarding sensitive information and maintaining trust in digital interactions.